Let's talk about object-oriented programming. So object-oriented programming, or OOP for short, is basically a programming paradigm. And we've already talked about classes and objects, and you might be asking, what is the connection between that and OOP? And that's a very good question. Basically, classes and objects are the building blocks of object-oriented programming. Now, what do I mean by this? Initially, OOP was made to model real-world objects. And basically, the reason why it was done is to make it easier for developers to develop software. Now, think about it. How much easier it is to have your code reflect the real world, as opposed to having to write cryptic symbols that then you have to translate to what it means in real world. Right? So that's how you can think of it. I mean, that was the reason behind the making of OOP. But as the time went on, OOP actually evolved into something more. And it evolved into a way in which we can write more flexible, maintainable, and scalable software. Now, as mentioned, objects were the building blocks of OOP, right? So let's actually talk about that a little bit. So the idea behind objects is to be able to expose data and to be able to expose functionality that the user has access to that can manipulate this data that we're storing. So, in other words, objects give us an opportunity to be able to expose functionality, yet hide its implementation. And that's a very powerful concept, which actually ties into the thing that I'm going to talk about next, which is abstraction. And abstraction is one of the most fundamental concepts of OOP. You might be asking, what is abstraction? I basically just defined what it is. It is us being able to expose functionality yet hide the implementation. The reason why this is powerful is because when we are hiding the implementation yet exposing the functionality, we're making it easier for other developers to use our code because they don't really need to worry about the details. All they need to see is the thing that we're going to be returning them and the process that will be done for them. So they have expectations. When they use a certain method, right, that method will hide its implementation, yet it will return something. Even if that method is going through some very complex computations, the developer using that method doesn't have to know about it. So that's very powerful because it makes it, as I said, simpler for other developers to use the code that other developers have written for them. Now, this makes it so that many developers can easily work together, right? Because understanding previously written code becomes much simpler. So if that can be done, then larger teams can work together. If larger teams can work together, that means bigger software can be written which impact the world. And basically that's the bigger picture. One of the other things that I would like to mention is that OOP comes with very powerful features. Those are encapsulation, inheritance, and polymorphism. In this section and the next section, we'll be talking about all of these features. But for now, in this video, I will be going over inheritance, and then the rest we will talk about later. So let's see this example. I basically have a person class, and I'm instantiating with John and Smith and the constructor. It has two properties, first name and last name, and then it has methods. They don't have a return type, it's void, and you said walk, eat, and sleep. So they're just going to be printing things out to the console. That's all. Now let's actually run this. So this is just a person class being instantiated and says sleep, so it says I'm sleeping. Great, not much to it. But I also have made another class which is called superperson. Now the superperson is actually inheriting from person. What does it mean to inherit from another class? That basically means that you get access to their methods and properties. And in here, in superperson, when it says that it's inheriting from person, it can actually have access to walk, eat, and sleep. And it also has access to person's constructor. And that's where the base reserved keyword comes in. We're basically saying that whenever you're instantiating superperson and you're passing in first name and last name, basically use person's constructor to construct the entire object. So that's why we do the base reserved keyword, right? That's why we do base first name, last name. So we're passing whatever we're passing to superperson. We're then passing it back to the person. So then the person will end up having that and construct the object for it. And also give access to walk, eat, and sleep. And you see that the constructor for superperson is actually empty. In this case, we can leave it empty, but you can very easily construct more stuff. So you construct the first name and the last name, obviously, right? Because that is part of the person. But whatever belongs to the superperson, you can construct it in its own constructor. So right here. And you can also notice that superperson has a method called fly. Now, this is only available to superperson. If you try to call it on person, the person won't be able to access that. And we can actually prove that by saying fly. See? It does not have access to it. So it's underlined red. Doesn't have access to it. We can go ahead, though, and say superperson, person2 equals superperson. And we can say John Doe in this case. And say person2. And we can actually say sleep. But how did that happen? And I forgot to use a new operator, so now we're good to go. But person2 has access to sleep, yet if we go to superperson, it's nowhere to be found. How? Because it's inheriting that from the person. But I can also say, remember how person1 didn't have access to fly? I can actually say person2 fly. So it can sleep and then it can fly. Let's actually go ahead and test that. See, I'm sleeping, and then I'm sleeping, I'm flying. So this is beautiful because through inheritance, we're actually able to reuse code. Remember, don't repeat yourself? So we don't actually have to go on the superperson and say, well, this is how I define, walking and eating and sleeping. The way we have done it, eating and sleeping, right, on the person. The superperson just gets those automatically when we inherit from the person. And this is just one of the features, and a very simple example at that, of inheritance. But there is other features such as encapsulation and polymorphism, which are also very, very powerful, and we'll be going over them, as mentioned, in this section and in the next one as well. So stay tuned.